Okay, so progress on the universal amplifier build. So I cut this acrylic down, rounded over the corners, and perfect fit. Fits right in there flush. I mean, it's like you bought it that way. Perfect. So now what I have to do is I gotta lay out and drill a bunch of holes in the top, bottom, and a few in the sides for ventilation. It's one mistake I see people do is they'll drill like a row of holes for something that needs to dissipate a decent amount of heat. Well, you need quite a bit of holes. So yeah, I'm probably going to have 4 or 5 rows of holes in the top and bottom of this thing. Next thing is I mounted the heatsink onto this L bracket. I was concerned this heatsink's a bit small. I don't really have anything else to use, so this will help make up for it. And I have to make sure I have room. I have the fuse holders and connectors. I have to make sure I have room up front for the volume control and the switch. So the heatsink will face, the fins will face towards the front. So I'll have to remove the amp board from this little heatsink bracket here because I don't need it anymore. And when I do, it'll mount like this down on the back. I'll position it so it's probably over here. Well, I need room for this virtual supply splitter thingy, so I don't have to go somewhere. So I have to watch out for, fuse holders and things stick in the way. So do that. And really, after that, it's just soldering and mounting everything up. And this thing will be done. I'll have me, hopefully, a nice little universal amp I could use with batteries, different voltages, and something I could take with me, be very portable, pretty small. Okay, so I have all the hole positions made in the lid. So I lay out even where the heatsink's going to be inside. And at each intersection, I just take this drill bit and I just line it up and make a little notch there. So when I drill the pilot hole, I can feel kind of where to put the drill. Put the bit right in that hole and then drill it. So what I do is I drill 1/8 inch pilot holes, then I'll come back, use the 1/4 inch bit. Now these bits are special, as you can see here, compared to a regular drill bit. Get a shot here. See, the bit for plastic on the right is more pointed. See those flat areas? Or this type of ordinary drill bit where you use for wood and such is flatter and it doesn't have those flat areas. Well, these work a lot better though. They won't gouge or crack when I'm drilling the acrylic. And these are something you can't buy at your local home store. You have to go online to like a place called Craftix or some other plastics fabricating type business and buy these drill bits. If you drill a lot of plastics, I would recommend getting a set. So I have to drill the same pattern on the bottom of this box so the heat can come up through the bottom and exit out the top. Of course, I'll have to put larger feet on the bottom so there'll be some space for air to get into, and I'll have a couple rows of, well, one row of holes on each side, you know, to help a little bit as well. But I can use this finished, you know, once I drill the pilot holes, I can use this top lid as a jig. I can tape it down with double-side tape and use it to drill the pilot holes into the bottom, so I don't have to line all this stuff up and go through all this rigmarole again. You know, just save some steps. I should mention for the lid, this is kind of a gray tinted acrylic. It looks black, but you can actually see through it a little bit. No real reason for using it. You could use black, but you know, I had this piece, so that's what I'm using. In the middle of drilling the vent holes, so what I did is drilled the pilot holes first, then follow it up with the finished holes. When drilling a 1/4 inch, which is about 6 millimeters, or larger diameter holes, I would recommend drilling a smaller pilot hole first so you get a cleaner cut with the drill bit into the material. Well, before I finish putting holes for the components, here's the finished vent holes. I just put some vent holes on the bottom because, you know, the bottom will be more covered than the top would, so I figured some in the lower side, allow a little extra air coming up from the bottom. But yeah, nice flush fit, countersunk screws. Looks like I bought one. Looks just like I bought one. Alright, well, I shall continue. Okay, so I have the amp board mounted in. Get this mounted in. So I'm just checking clearances here. So with this all the way back, make sure I can still fit the volume control in there. Yep, we got plenty of room. So I'm going to have to cut all the holes, square, rectangle hole for the switch. Power jacks. I think I'm going to go from the power jacks through the diode, then the fuse, because I can just solder that right together, diode right between them, instead of power, fuse, diode. Normally you want the fuse as close as you can to the input, but it doesn't really matter in this case. So I have to mount the speaker terminals. Like I said, I like to use these. They're just simple and easy. So I have to route a slot for these connectors. It'll fit through like that. It'll clear these capacitors when this board's mounted in, so there's plenty of room there. So yeah, we're getting there, almost done. Just gotta mount the components to the case, do some soldering. Did have to extend the wires on the board. I just put new input wires in because the other ones were too short to reach around to the volume control. So a nice tight twisted pair on those. No, I'm not going to use shielded cable. It's not necessary. But yeah, we're getting there. Not much longer and this will be done. Progress report check-in. I got all the components mounted to the back. Front. It's a nice switch. Volume control. It's a nice volume control. It's got little gliders or little contacts, or there's like 3 of them per side. So it should be a good long-lasting control. Still got to do the LED. And this fits right in there. Maybe. Yeah. So, yeah, I got to drill holes for this yet. God, this job, it just goes on and on and on, these little projects. I got slotted again, slotted screws. Thanks to Radio Shack. I don't know why they sell slotted screws. Only thing I had that would fit. Okay, it's all together now. Looking a little messy in there. But each wire does its own thing. I gotta clean that tape adhesive off of it. When I mark the holes, I put tape down. Draw lines on that. Back. So now let's hook it up and see if it works. Okay, we got some speakers hooked up, input to the music player, and I'm just clipping onto the supply here. I want to run it off the supply current limited. Whenever you first test an amplifier you built, make sure you limit the current so you don't release the magic smoke if there's a problem. I always hear in the comments section that, oh, I just got this such and such amp and I powered it up and it smoked or something. So we'll start at half an amp, 9 volts, power it up, and turn the power on in the front here. Okay. Looks like we're using 70 milliamps, about what I expect. But is that light on? No, that light's not on. But does this thing work? Let me find some music real quick. Would that stuff be copyright? I don't know. Yeah, it's playing. No LED. You would think I'd be able to hook an LED up. So hang on a second. Okay, I checked. There's no voltage at that LED. So I think what happened is there's on my board there's little traces that connect to holes, and I must have soldered one of the leads into the wrong side. I have the positive to the positive and the negative goes to the negative side, so I think I just put it into an adjacent hole that doesn't have power, so I will have to fix that. Good thing is this is easy to service. So I just take out those 2 screws in the base there, and you can tilt this up and out. Doesn't look like there's room with all that stuff in the way, but yeah, I made sure I could get at it. But what I want to do now is check the balance of the supply voltages since we're using this rail splitter here. Now I can't hold the camera and take all these measurements, but I'm finding there is some imbalance, which I kind of expected, having 2 amps on there. So I'm putting 20.3 volts. I'm doing the 0.3 extra to make up for the diode drop, so I get 20 volts on the input here, or 10 on each rail, measuring from the virtual ground. So I'm getting 10.7 on the positive rail and 9.3 on the negative rail. So there's a little bit of an imbalance there. So what I can do is put a resistor across the rail that has the higher voltage. So that would be the positive rail. Well, I don't want to desolder wires or anything, so I'm just going to try some different values, see what balances this thing out. So what worked out was a 15K resistor. So putting a 15K here. So I'm using 2.2Ks as the main balancing resistors. So we have that bit of imbalance. I'm going to use the 15K to balance it. So when I do that, I get very close to 10 on both rails. What I'll have to do is solder that guy on the board there, and of course we'll get the LED going. But for now, let's take a power measurement. I'm going to crank this thing up. Yeah, there's clipping. We'll pull it out of clipping. I guess right about there. Get some waveforms on the screen. 9.31 volts. We'll punch it in the calculator here. 9.31 squared divided by 4 ohms. 21.6. So yeah, I have both channels driven here. 4 ohm load, set for 4 ohms. Yeah, that's about what I would expect. I am running it at 32 volts, which is high as I can get on one channel of my supply here. And you can see we're drawing 2.15 amps. So it needs about 60, whatever that would be, 64, and close to 70 watts. So that would be 40 watts out of this thing, so 30, additional 30 or so watts. It's working okay, doing what I would expect. Now let's see how low of supply voltage I can go before it starts to shut down. So I'm at 5 volts now. At 4 volts, I can hear some distortion. Right at 3 volts it craps out, and it comes back around 3.3 volts. So yeah, this thing will run on real low voltages. You only get a few milliwatts of output at such a low voltage, but yeah, it will run at quite low voltages. Just doing background music, why not? Okay, I'll go ahead and fix the LED and put that resistor in there and button the thing up. Okay, let's wrap up this video here. I don't remember where I left off a couple days ago, but got the amp back together, lid attached. I put these large feet on the bottom to keep it up off the table so air can circulate. Not that it's going to get real hot, but yeah, it'll be good. So I'm plugged into the solar panel. It's an overcast day, but there's enough light. I think we can run the amp. So the panel comes into these capacitors here, this bank, and that's the panel voltage right now. There is a load on it. There's some LEDs that light up the bathroom. I don't have a window in the bathroom, so I light it by sunlight during the day with the little 12 volt switch mode power supply regulator thing there. And that will reduce the voltage down. Though with the amp you can just run it directly off the panel. You don't need a regulator or anything. 12 volt panel will put up to 22 volts out, and at max power it's usually around 18 or so volts. So yeah, just if you wanted to run the amp on solar, just get like a 15 watt panel or something like that, and that'd be plenty. Here's the panel. It's a 30 watt panel I got 8 years ago. I don't know how long I've had it. We're getting some sun now. Okay, so I'll play some YouTube safe, copyright free bass music. I think we're just clipping a little bit. I should, I'm on the 12 volt regulator now. I probably should run direct like I mentioned, but I don't feel like rewiring it. Yeah, whatever. Yeah, I have this new power panel here. It claims to be 20 watts, but under the best conditions I can only get 17 watts out of it, telling me it's actually a 15 watt panel. Normally with a good panel you can squeak a little extra, like my 30 watt out there. I think I've been able to get like 34, and my 10 watt get like 11 or 12, but I've only been able to get 17 out of this thing when I tested it at maximum power. So yeah, it doesn't really look like a 20 watt panel anyway, given the size. So there you go, the completed universal amp project. You can run it on multiple voltages, and you don't have to worry about a dual supply. That was the idea. You can just plug any old supply into it and go to town. Well, that's it. Stay tuned for more. We'll catch you on the next one.